Repeated engine failures? We will show you how we can help you find the cause in this video. When an engine fails, you don't necessarily think directly about the cause. People think of material faults or other one-off causes. The engine is often replaced and then runs again for another time period. However, if the motor fails repeatedly after a short period of operation, you start to ponder the possible causes. Mechanical stresses are checked, lubricants, cooling, current consumption, and the correct electrical connection are scrutinized, and all protective devices are tested for their effectiveness. If no fault is found after all these measures, the question of how to proceed is not easy to answer. The first question you should ask yourself is the motor operated via a frequency inverter? If so, you've come to the right place in this video. With the increasing number of frequency inverter operated motors, bearing damage like this is becoming an increasingly common problem that can lead to failures. Depending on the application, bearing damage can occur after an operating time of several weeks. Even if the damage is so slight at the beginning that it is barely noticeable, the bearing will continue to be damaged as operation progresses, so that the engine can no longer be operated at some point. This is often caused by so-called bearing currents. As the name suggests, these currents flow through the bearing and damage it. You can find out how such bearing currents occur, why they are connected to the frequency inverter, and what you can do about them in our video on the subject of bearing currents and BCR filters. If you are new to the topic, we recommend pausing the video at this point, watching the video just mentioned first, and then returning here. You will find the link to the video in the video description. Recognizing and evaluating bearing currents is no easy task. You would have to measure the current to be able to recognize and evaluate it. To illustrate the problem, let's take a look at a motor. A simple current measurement with the usual measuring devices, such as a multimeter or a current clamp, is simply not possible due to the motor design and the position of the bearing in the motor. In addition, it is not possible to determine exactly where the currents flow. It could flow off in all directions via the housing. For an exact measurement, the entire bearing would have to be measured. As it is not possible to measure the current directly, the only option is to measure it indirectly. In other words, using the differential current measurement method. This is because the current flowing through the bearing flows to earth via the earth housing and thus creates a difference in the current sum of the three phases, which should ideally always be zero. To put it simply, everything that flows via the bearing is missing in the three phases. Now it would be very simple to enclose the three phases of the motor cable within a current clamp and read off the differential current. However, there are two major problems with this measuring method. Firstly, the current clamp cannot detect high-frequency currents generated by the frequency inverter, which means that the measurement results only corresponds to a small part of the truth. The bearing currents that are to be measured flow in high-frequency range, so at several kilohertz and megahertz. Secondly, only one value can be read on the current clamp, which is also subject to a certain inertia. In view of the fact that the bearing currents are rather high frequency, short, possibly very high current pulses cannot be recorded at all. Furthermore, it is more than difficult to evaluate the displayed value, as it does not provide any information about how high the dangerous current pulses are. Only an average value can be read. However, this information is indispensable for an analysis and subsequent selection of countermeasures. High pulses in particular are very important. Here is a short excerpt from our video on the subject of bearing currents. In search for weak points of the insulation, it arrives at the motor bearing. As soon as it has found a weak spot, it breaks through all of the surfaces and the insulating lubricant in the bearing and leaves damage along the way, as we saw at the beginning. During operation, our little devil is not alone. Permanently, these little guys are available in the motor in different sizes and in varying degrees of anger and try to break through. Each of these breakthroughs is one of the aforementioned high current pulses. Our DiffDi residual current diagnostic system is used to record and analyze precisely these pulses. Specially developed for measuring and analyzing bearing currents, it offers the greatest possible flexibility when measuring and a wealth of evaluable information about the measured value. The DiffDi residual current diagnostic system consists of the measuring unit and the permanently connected Rogowski measuring coil. To carry out a measurement, the measuring coil is placed around the faces of the motor cable like a current clamp. Ideally, the measurement is carried out directly on the motor, so in the motor terminal board. The flexible measuring coil enables installation even under difficult conditions. If a measurement directly on the motor is not possible, the measurement can alternatively be carried out in the switch cabinet behind the frequency inverter. The measurement results are more accurate the closer the coil is placed to the conductors. For smaller cable cross-sections, the coil can be wound around the conductors up to 3 times. However, this must be taken into account in the software, but we will come back to this later. Once the DiffDi soft has been installed, the measuring unit has been connected to a PC or laptop via USB and the software has been started, the measurement can begin. At the beginning of the measurement, the limit values for the motor to be measured must be determined. These are required in order to be able to evaluate the currents measured later in the relation to the motor. 2 methods are available for this: determination via the bearing types installed in the motor or via the rated motor data. We recommend determining the limit value via the bearing types. This data can be found on the motor rating plate. The start screen directly shows an example motor rating plate, marked in green, where you can read the motor bearing types. The bearings are labeled differently depending on the manufacturer. A list of the common designations can be found directly in the drop-down menu on the right. After reading, we select the option via bearing types in the start screen or in the limit values tab at the top left of the settings. The bearing types are selected via the bearing size drop-down menus. If these are not specified on your motor, you can alternatively specify the motor power and speed, highlighted in yellow in our example motor rating plate. To do this, we select via motor data in the settings and set these in the corresponding motor data drop-down menus. The following applies. The speed corresponds to the field speed and may differ from the information on the rating plate for asynchronous motors. Select the value that is closest to the value on the rating plate. As soon as both fields of the bearing types or the motor data are selected, the recommended limit value of the peak currents can be read. Under the Settings tab, you should then check whether the correct number of windings is set under the hardware selection in the hardware settings. Depending on how often the measuring coil was wound around the conductors, the corresponding option can be selected in the drop-down menu. V1 stands for 1 winding, V2 for 2 windings, and V3 for 3 windings. The measurement is now started in the Live Measurement tab with the On/Off button. The motor must be running for this. The current live measurement signal should now be visible. The red colored part indicates the range above the recommended limit value. The most important values can already be read off in figures on the right-hand side. The next step is to check whether the set measuring range is correct. By default, this is set to Auto, which means that the measuring range can jump up and down again and again due to the high fluctuations. It is therefore advisable to select a manual measuring range. It is best to start with a relatively small value. If you then notice that the yellow warning symbol appears, this means that the measuring range has been set too low. Increase the measuring range until the yellow warning symbol no longer appears. The scaling of the 2 axes is normally set to Auto. Manual entry of the scaling is also possible under the graph options and, as in our example, also makes sense. Before entering a value, you should check whether the Y-sync checkbox is ticked. This has the effect that the value entered for Y scaling is transferred directly to the following measurements and the result is therefore more comparable. All parameters for a measurement are now set. However, the changes are usually still too fast to be able to carry out a reasonable evaluation. For this purpose, a period of 10 seconds can be recorded in the initial measurement tab and then analyzed. Click on measurement to start a 10-second recording. As soon as this is finished, the result is displayed. This measurement can be saved and reopened later anytime, even without a live measurement taking place. The red dashed line shows the highest current pulse. In our example, there are relatively many current peaks in the red range, and the dashed line is therefore also well into the red range. The sum and the height of the current peaks that occur and reach the red area should be evaluated here. The more and higher the peaks are, the greater the load on the motor. We now know that our motor is exposed to quite a high load due to bearing currents. Now the question arises, what can I do about it? At this point, we would like to refer you once again to our BCR video, in which everything is explained in detail and clearly about bearing currents and how to reduce them. Without going into more detail in this video, we will install a BCR filter between the frequency inverter and the motor as a measure. The DiffDi measurement setup can remain active in the meantime. After installation, a second measurement must of course be carried out to see whether the measure has had the desired effect. In the software, however, we do not simply start another measurement, but leave the measured period in the initial measurement and move on to the final measurement. Here, just in the reference measurement, a 10-second measurement can be carried out without overwriting the initial measurement. You can immediately see that the measured values are significantly lower and all values are now below the limit value. Here too, the measurement can be saved at any time. To display the difference even better, there's a Compare tab. The graphs are initially empty here. Click on Get Measurements to import the previous, initial and final measurements into the comparison window. Depending on the display method selected, both measurements are now displayed either separately, superimposed or as a bar chart. For further optimize the display, the envelope curve of the measurements can be activated. Finally, the entire measurement section should be saved again for further use. The export area offers several options for this. In each tab, there is the option to create a full screen screenshot. In addition, you can create screenshots of all three tabs at once in the Compare tab by clicking on 3x Screenshot. With the graph export, only a screenshot of the graph is created. This concludes the measurement. The DiffDi residual current diagnostic system therefore helps with the initial analysis and evaluation of the measures taken to reduce the bearing current. The exported screenshots can be easily integrated into a measurement report to create professional documentation. You can find all information about the product at www.diffdi.de. If you have any further questions about the differential current diagnostic system or the BCR filters, please contact our technical support team. We will gladly advise you.